Okay, more on using the 7-5 properties that we've learned to solve equations. So up here, we were separating the logarithm out. We started with one log, we turned it into two separate logs, recognizing that we can use multiplication. Multiplication can become addition, and the division can become subtraction. So down here, they're going to give us this addition. I can recognize that that can be combined into multiplication. So log base 7 of 27 times 3. And again, this works as long as they have the same base, which they do. And then I remember this cool rule that says that if I had an exponent, I can bring it out. So I'm just going to put it back up. And then I'm going to remember this cool rule from 7-4, I believe it was, that said, hey, if you have a log on each side, just one log on each side, you can cancel them or drop them as long as the base is the same, which in this case they are, and there is only one log on each side. So what I get to have now is x squared equaling 27 times 3 is 81. And that is an easy equation to solve. All I have to do is the square root, because the square root of a square cancels it, and x equals the square root of 81, 9. Now, like I did the other day, I recommend plug it in just to double check real quick. When I plug the 9 in up here, that's still positive, nothing changes on those. So yes, 9 does work as a valid answer. Let's try 4b. The way 4b looks is, again, same base, so I can combine these items. X parentheses x plus 5. Sorry, those should have a log base 6. I got ahead of myself a little bit, didn't I? Equals 2. Ooh, I don't have a log on each side this time. Oh no, what do I do? Well, remember your circle rule? You might want to write this down because this is the most easily forgotten rule. If you have one log, the way to get rid of it is the circle method. 6 squared equals x parentheses x plus 5. And now from here, I know it's not our favorite, but I'm going to have a quadratic that I can solve. Okay, minus 36. You can use the quadratic formula. You can factor. My go-to is normally factoring. So I ask myself what adds to 5 and multiplies to negative 36. And let's see. Looks like I'm going to have to maybe figure this out for a second here. Hang on. 1 and negative 36. Oh, wait, hang on. I just figured it out. Haha. Right, if it was 9 and negative 4, that would be a negative 5, but a negative 4 and a 9 does add to a positive 5, and it does multiply to a negative 36. Okay, great. So 0 equals x. Oops, that's not what I wanted to do. Yeah. Minus 4 plus 9 make it two different equations. Oops, there we go. And then again, I would double check and plug those in. Because it looks like, and again, you actually are going to want to plug them all the way back into the original up here. And when I plug in 4, no big deal, right? It was positive 4. Positive 4 plus 5 is 9, and this is just a positive 4 over here, so that's okay. But when I plug in that negative 9, I have a conflict here. Again, I can't have negatives. So the negative 9 is not a valid answer. but 4 is.